So, Google just dropped a brand new AI model called Gemma 412B, and honestly, it finally bridges a massive gap that a lot of developers have been complaining about for a while. If you've been tracking the Gemma 4 lineup at all, you already know how it went. You had the tiny edge models like the E4B, and then you had the massive 26B mixture of experts. Now, that big MOE model runs incredibly well, but it demands a seriously powerful machine. Before now, there just wasn't a solid option sitting right in the middle. The 12B is exactly that missing puzzle piece. It's designed to give you almost all the intelligence of the larger flagship model, but it's light enough to run locally on a standard laptop with just 16 gigabytes of memory. Keep in mind, Gemma is Google's open-weight family. Open-weight simply means you can download the actual model files and run them directly on your own hardware. No API keys required, no monthly subscription bills, and zero data leaving your local machine. You own the weights, you own the inputs, and you own the output. Period. Now, when Google originally dropped the Gemma 4 lineup earlier this year, it landed in a few different sizes. We got the tiny E2B and E4B built strictly for phones, the heavy-duty dense 31B, and that interesting 26B mixture of experts that only spins up 4 billion parameters at a time to stay fast. Crucially, every single one of these models is multimodal, meaning they natively process images, text, and even audio. On top of that, the entire lineup is released under the Apache 2 license. That license matters a lot more than people realize. It means you can use it commercially, build real products, ship them to paying clients, and you don't owe Google a single dime. For businesses, that is a massive win, because closed models tend to lock you into per-token cloud pricing forever. The real reason this model family is exploding right now comes down to what the community is actually building with it. Gemma 4 has already crossed 150 million downloads, which is a huge milestone for an open ecosystem. The multimodal capabilities are where things get really fun. Because the model can look at an image and deeply understand a user's display, developers are creating tools that interact with your desktop just like a human would. Google built the 12B to be completely encoder-free. For vision, they replaced the bulky encoder with a microscopic embedding module, basically just a single matrix multiplication and some normalization. The core language model then processes the image data directly. For audio, they took it a step further. They projected raw sound straight into the same space as text tokens. No audio encoder whatsoever. Because of this, images and sound stream straight into the model's primary brain without needing translation first. You get lower latency, lower memory usage, and it's the very first mid-sized Gemma to support native audio input, something the larger 31B and 26B models can't fully do. Having a local open-weight model that can see, hear, and reason close to the level of massive models while fitting on a standard laptop under a fully commercial license is incredibly rare. It fundamentally redefines what independent developers and small teams can build without taking on massive cloud expenses. That wraps up our breakdown for today. If you found this helpful, make sure to drop a like, subscribe to the channel, and I will catch you in the next video.